maybe one or two, maybe three. We'll see. Let's start with question number 2. This is for the homework for chapter 7. Yeah, this is a good one. So with these ones, we're given a graph. We're given a z-value here. And we can see that basically that means that's what these boundaries are, a +1 over here and a -1 over here. And then we're asked questions about which one of these pictures, and this would be a -1.75, be a +1.75, which one of these graphs has which of the p-values. So we've got a p-value here, p-value here. What you're going to see is the p-value is the area that these things represent. So notice this of p.3524, that's 35%. But which one looks like 35%? This one here. And over here, this is about 8%, right? So this one is going to be a p-value 0.081801. Now, what I want to show you, though, is how we can use the calculator to come up with that. Notice they're using a normal distribution. So we come over here. We can go down to our normal distribution. Use this before. And this is the two-tailed test. Now, this since this is standard normal, we'll have 0 and 1. And then we're going to use the one between. Notice we have to kind of do this a little bit. It's not going to give us the tails. It'll give us the middle part, but we can get those tails. So let's do this first one, A, of 0.93. So what I would put in is -0.93 and then +0.93. I get over here a percentage, 64. It doesn't match up with this, but notice that's the middle percentage. So if you subtract 1 from this, subtract this from 1 minus this, we will get 0.3524. To be sure, we're going to go Shift, copy. This says, notice in yellow says copy. We just copied it. We're going to go to the main calculator, or the regular calculator. We're going to go 1 minus. This button is the paste. If I do the Shift, paste, go ahead. So I copied it in there, and that's 35.3523, rounded up to 24. So that's this one. So that checks out. But visually, I could see, yes, that's the one that's about 35. Over here, we can do the same thing. The important part is I need you to see how we can get those values for the distributions by using the distribution tool. 1.75, and then I put in +1.75. I get that. Remember, this is the opposite. This is the complement of what I want. Copy here, and we're going to go 1 minus, paste. Yeah, we'll allow it. And you'll see that that's the 0.0801. 0.0801. So those match up. Okay. Let's clear this off. And so what we say, the graph A displays the area for that. Yeah, so it's got the 34%, 35%. And then graph B will be the lower percentage. The p-value is related to 1 minus, is equal to 1 minus, is related to, is equal to the shaded area. So notice the area, shaded areas, is what the p-value is equal to. We had to subtract it to figure it out, but we got there. Okay. All right. Let's take a look. Now this would be a one-sided. Again, we don't have to do both of them. but you could see definitely B has a larger percentage, so it's going to be the larger P, about 26%. And these are a little easier to figure out because you just go down to your distribution. This is a left-sided test, so I go to the less than, and I can just put in my Z value of minus 0.63. And notice you get that area of the curve is 0.2643. So this matches up directly with that area. And you can answer those from there. Okay, and over here, you're going to see that this little area goes with that one, and just plug that in, and you can use the distribution tool. Okay. So let's look at a question. I think down here, maybe 6, we get into one where we're actually going to do a hypothesis test. Okay. Oh, they're giving us a different calculator, but use the calculator display to make a decision to reject or fail to reject the null hypothesis at a significance level of alpha equals 5. Key part you're looking at here is this calculator. Ours would maybe do a little differently, but they've calculated a p-value here, 0.3563. So we get p equals 0.3563. That's bigger than the alpha, right? It's bigger than 35%, is bigger than 5%. We do not reject it. We need to be smaller than the alpha to do that. Okay, since the p-value is greater than alpha, fail to reject the null. Okay, that's what we got to do. Okay, so nothing too. The null hypothesis always has an equals in it. Nutrition claims that the mean tuna consumption by a person is 37 pounds per year, or 3.7 pounds per year. That's an equal, and there's only one with equals here, so this has to be E, right? It's not less than, or at least, or it's a person's consumption is 3.7. And so that would make the alternate hypothesis not equal to. Okay, well, let's go through this. Sample of 60 people shows that the mean tuna consumption by a person is 3.3 per year. Assume the population standard deviation is 1.16 and an alpha of 5. So we'll check our answer as well. Yeah. So what we have to put in here, do this one and then we'll leave it at that. We're doing a test. We're doing a mean, one mean, and this is going to be a z-test because we know we're given the standard deviation of the population. Okay. So our null, we said is going to be equals to 3.7, and giving us the alternative hypothesis of not equals. Two-tailed test. We go in, the sample found a 3.3 average. The population average is 1.16. And the sample size was 60, a sample of 60 people. We're asked to do an alpha of 0.05, which is a standard, or the default, I guess I'll say. So our z is this, our p-value is 0.007, which is less than 5%. It's 0.7%. It is less. We're going to get to reject it, but they're going to ask for various things like the z is going to be negative 2.67, 2 decimal places. Check our answers. Yeah. P-value, again, we're given that right here, 0.0075, 3 decimal places, so we'll go to 8 to D, so that 7 gets rounded up to an 8. Okay, perfect. And then do we reject? Well, yes, and we can see that here. Well, you don't even see any shading for the p-value, but it's so far we're definitely in the rejection region. So we are going to reject H naught, which means there is sufficient evidence to reject the claim that the mean tuna consumption is equal to 3. So that's what happens when we reject. It means we've got enough evidence to show that the alternate is true. It's not equal to 3.7. Okay, check our answers. Excellent. Okay, so that's how hypothesis testing works. This will work the same way. The only thing is they give us data. So when you go to put this one in, you're going to choose the option, use a data set, and then you'll have to enter all this data. You don't want to see me do that here. It's tedious, but you would start entering this data, 14.4, and you can go either way. I guess we'll go down the columns, 19.6, and you're just going to enter all this data, and then the test will look, it will calculate the mean for you and take it from there. Okay, so that's that. Hopefully this gets you started. You should be able to see the NumWorks will help you set up and process the hypothesis tests.